Hello, here we are in section 6.3. It's entitled More Factoring Trinomials. Now what the heck does that mean? Let's take a look at this guy right over here. Let's put that. It looks like it's something that we've done before. We have squares, x's, and numbers. It's a trinomial. Let me copy that here on my board. 2x squared and minus 5x minus 12. And what we have here is, let's make a nice 2 here. And what we have here is one big bundle that needs to be broken up. That's what we're doing. We're taking big bundles and factoring them to smaller bundles. And what makes this different from section 6.2 is look at the number in front of the x squared. The number in front of the x squared is not the simple number 1, but the number 2. So when you see right here is this expression, we cannot factor anything out of it. No, there's no greatest common factor. We can't pull out an x. There's no x here. And take a look at the numbers. There's no numbers that divide evenly into 2, 5, and 12, other than 1, and 1 doesn't count. So we have to leave this alone. And when you leave it alone, you're left with a number in front of the x squared. And that complicates things. So what I'm going to do is show you a technique that really isn't described in the book so much. It's a technique that I developed a few years back, and it always works. And it always seems to work. So let me show you the technique. Here's what you're going to do. First thing you're going to do is you're going to factor out the greatest common factor. Well, there isn't any, so that's step 1. Step 2 is take this expression and rewrite and come up with another expression with the 2 just simply removed. I'm not factoring the 2, I'm just removing the 2. So I'm going to make this x squared minus 5x, rewrite the middle term, but the 2 that you removed here is going to be multiplied by the 12 to give you 24. And I should say that the 2 that gets removed, I'm going to put off to the side, I'm going to circle it, and I'm going to call that the magic number technique. The magic number. This is the magic number technique. The magic number technique, where the magic number is simply the number that's in front of the x squared. Push it off to the side, circle it, because that number is magic because it gets involved in a lot of the future steps in this algorithm. Okay, so what you're going to do is come up with another expression without the 2 in front of the x squared, copy the x term, take that magic number, multiply by that last number, minus 12, to give you 24. Now this you can factor. That you can factor. That's not going to be a problem. That's going to give me x and x. This is the same thing that we did before. I see a minus 24, so that's going to be plus and minus. So now I need 2 numbers that multiply together to give you 24. Add or subtract to be 5. And I think I'm going to go with 8 and 3. 8 times 3 is 24. We'll subtract to be 5. I see a negative there, so I'm going to put an 8 there and a 3 here. So, okay, that's not. But this is not the answer now. Don't understand, this is not the answer. We're getting to the answer. The next thing that you're going to do is you're going to say, well, this is nice, but it's not the answer. What we're going to do is make fractions out of these numbers. Make fractions out of those numbers using this magic number. I'm going to make a fraction here and make a fraction here. The next step is you're going to simplify those fractions. Let's see, 3/2 can't be simplified. It is what it is. Okay, but 8 over 2 can be simplified to be 4. So let me copy this down. That's all I'm doing here. One step to another, 3/2. Okay. Now, after simplifying those fractions, if you still have a fraction, what you're going to do is take the denominator, put it in front of the x term, and then you're done. And then you're done right there. Okay, see, I didn't have to look at these answers here. Now, you could have got this problem by simply factoring these two and seeing if you get this answer here. But I wanted to see, I don't want to see these answers here. Can we generate that? Look at this. I get 2x plus 3, x minus 4. I'm going to go for that as an answer. Final check. Good job. Great job. So we got the answer without doing it. So it looks like a complicated algorithm, but believe me, the alternative is to do what's in the textbook, and that is a complicated algorithm, much more complicated than what I'm showing you here. Again, I'm calling this the magic number technique. It's not the official math term that they use in textbooks, but it describes how you can factor this. Because it's kind of magic in the way that this number that's in front of the x squared, this number 2, gets involved in all these steps. So we're going to do a couple more, a bunch more problems. Let's try. Let's do a new. Let's clear this out. Don't save it. File, new, and then we're going to create a new canvas here. Let me scan ahead. See, all these problems are going to end up looking like this. So let's do, excuse me, number 2. That's kind of boring. Okay, let's do this one here because they're big on using the same number 2 all the time. Here, let's do number 3. Come on. I was just there. Come on, you can do it. Let me do it another way. The website is not agreeing with me. Come on. How about this? I'm going to make up a problem. Pretend this is problem number 4. There it is. There it is. The internet's slow here, I guess. Let me write down 3c squared minus 14c plus 8. Okay. Step 1. I'm going to use the magic number technique. Step 1. Can we factor anything out? You've got to make sure you can factor something out first. The magic number technique doesn't work unless you factor something out. Well, step 1, nothing you can do here. Can't pull out a C, you can't pull out a 3 or anything. All right. So here's what you're going to do. You're going to, step 2 is you're going to convert this expression to something that we can do. Now, what do I mean by that? We're going to take the 3 that's in front of the c squared. I'm going to put it over here on the side. I'm going to circle it because that's the magic number. And I'm going to rewrite this expression to be without the 3 as c squared. Keep the middle term, 14c. But this number that's over here is 3 times 8, which is 24. Okay? Now this you can do. Okay? Because you did this in the previous chapter. That you can do. That's going to be c for c squared. I'm going to go with double negatives because you need double negatives will multiply out to be positive and generate a negative in the middle. And now what we need is 2 numbers that multiply together to give you 24, add or subtract to be 14. And I'm going to go with 12 and 2. 12 and 2 would, I think, do the job. You can prove that to yourself. Just FOIL it. You'll get the negative 14 in the middle. The next step is to make fractions out of these numbers using the magic number. So these numbers here, I'm going to do divide by 3, divide by 3. The next step is to simplify the fractions. Well, 12 over 3 is 4. That's 4. Okay, that's simplified. 2 over 3 cannot be simplified. Can't be simplified. So if you still have fractions after you simplify it, what you're going to do is take the denominator of that fraction, put it in front of the variable c, and what you're going to do is say 3c minus 2, and you know what? There's your answer. There's your answer. So I'm going to push this off to the side. I'm going to say come over here. Okay, c minus 4. And this is going to be 3c minus 2. Close that. Check your answer. That's it. It works all the time. This magic number technique works all the time. Let's try another one. Let's do every other one, say. Let's do this one. Let's do this one. Okay. No need to do every problem. Every problem, if we do every other one, this is a good stab at doing the homework for you. So let's try a file, new. This will prepare you for the homework. Absolutely. Okay, and that's how you learn math. It's like going to the gym. Okay, you're doing reps. That's the only way to get strong, is to do things over and over and over again. This is what we're doing here. Okay, copy the problem on your paper here. 5x squared plus 7x minus 6. Step 1. You remember step 1? Factor out the greatest common factor. There is no greatest common factor. Nothing. You can't do anything with 5, 7, and 6. Those numbers, the best you can do is pull out a 1. And 1 doesn't count. So what you're going to do next is say, well, I'm going to use Silvestri's magic number technique, where this is too complicated. I'm going to convert this to something that we can do, like a intermediate expression that we can do. And how we create that intermediate expression is take the 5, pull the 5 away from the x squared, keep the middle term. But this time, the number that goes here is not minus 6. It's 5 times minus 6, which is minus 30. Now go ahead and factor that. Now, there's this option, polynomials prime. If you cannot factor this intermediate expression, you could not factor the original one. So if you can't factor it, you couldn't do the original problem either. So that would be prime. But in the meantime, I think we can probably do this. Okay, this is going to be a negative 30 means a plus and a minus. So now what I need to do is come up with two numbers that multiply together to give you 30 and add or subtract to be 7. So I'm going to go with 10 and 3. 10 and 3 would subtract, yeah. The 10 I would make plus because I see a plus here and the 3 there. And there you go. We factored it, okay? But then the next step is to make fractions out of those numbers. Okay, simplify the fractions. Well, 10 over 5 is great. That's 2. 10 over 5 is 2. And 3 over 5 is already simplified. But if you still have a fraction, as we do here, you're going to take the denominator of that fraction, push it in front of the variable, and get 5x minus 3 as the answer to that problem. You could FOIL it and check for yourself, but I'm confident that that's the answer, because I've done this so many times. And check my answer. Great work, fantastic work. We're a third of the way done. Okay, a third of the way done. So let's see the next one. Let's see, they're looking the same. So let's come up with something different, a little different. Let's do number 8. It's not really different, but I like the pattern of the signs. So I'm going to come over here. Don't save this. I'm going to create a new sheet of paper. Okay. Move this over here. Come on, baby. Okay, move it over here. And the first thing that you're going to do is say 3c squared minus 14c plus 8. And we're going to say, well, geez, can we factor anything out? No. Okay, so what we're going to do is pull the number 3 away from the c squared, circle it, because that's the magic number. Write the expression out without the 3 in front of the c squared, copy the middle term. 3 times 8 is 24. That's the number there. We go ahead and This almost looks familiar. C and C, unless we had different signs. Yeah, we had different signs before. C and C, now we need a positive 24, negative in the middle means double negatives. And we need two numbers that multiply out to be 24, add or subtract to be 14 would be 12 and 2. That would be good answer. Now the next step is to make fractions out of those numbers. Simplify the fractions. C minus 4. 12 over 3 is 4. 2 over 3 cannot be factored, so it cannot be simplified. So what you're going to do is take that denominator, put it in front of the C, the variable, and there's your answer to that guy right there. See, you're a math machine at this point because you're following the algorithm. We're following that algorithm. Check it out. Well done. Let's see what the next problem is. Okay, well, let me do a quick scan of what the next problem is going to be here. That's a good one. That's a good one. That's a very good one. So let's come over here. First thing is clear this out. File, new. Okay. And first thing, you know this doesn't look right, right? After a couple of sections of doing these problems, you know you got to put the square term in front. So I'm not even going to waste the ink on this. I'm going to say put the 3a squared in the front, okay, with the sign, right? This is a minus 18a in the middle, okay, minus 19a here, and the plus 28 at the end. Okay, the first step, can we pull out something? Can we do a greatest common factor? No, there's no greatest common factor. Toward the end, there's going to be a greatest common factor toward the end of these problems, but in this case, no. So we need to do that magic number technique where we take the 3 away from the a squared and convert this to another expression that we could sell. You know, anything with an a squared, you have a chance of factoring. That should be a no-brainer at this point. But this time, what we have here is 3 times 28. Now, what's 3 times 28? 3 times 28 is going to be 84. 84. Okay? 3 times 28 is 84. Now, see, the problem with this magic, there's a problem with everything in life. And the problem is when you start multiplying numbers, like 3 and 28, you start generating big numbers. And that's the only issue with this, is I have to ask myself, give me two numbers that multiply out to be 84, add or subtract to be 19. And it gets harder to come up with two numbers that multiply out to be 24, add or subtract to be 19. So there's a website I developed, and you're going to have a link to this website in your course tools. I'm going to put a link to it in the website, but the bottom line is, let's open up another browser. Okay, you're going to have a link to this. Okay, so I'm going to go to what's called bytecodeman.com. This is my personal website. And again, you don't have to memorize this. You're going to go to, I'm going to have a link to this in your course tools. Now, this internet is not, oh, there it is, Bytecode Man. I'm the Bytecode Man. Special apps. So this is the link to the website that I'm going to show, that's going to provide some tools that I use for my classes. Now, in this website, I developed a bunch of little programs here. Number factoring is the one that you're going to use. Number factoring. And so when we go to number factoring, what we want to do is take this number 8 to 84. This number 84. Put that in there. Submit it. And it gives you a whole big report on the number of 84. Okay, it gives you a prime factorization. But what you care about is down here. Factor pairs, sums and differences. Because this is what I'm asking for. Give me two numbers that multiply out to be 84, but yet add or subtract to be the middle number 19. Plus or minus 19. I'm going to go with this guy over here. Look at, see this plus or minus 19? These are the two numbers that are involved in that process, 7 and 12. Because 7 and 12, let me minimize that because we might want to use that later on. Okay, there it is. So it looks like 7 and 12 are the numbers that are involved. So that website's just there to speed up the process. Okay, and so, and again, you're going to get a link to that. A and A. I think double negatives for the positive 84, 7 and 12. And I think if you do a FOIL, you're going to get the 19. Make fractions out of those numbers. Okay, I'll make a fraction out of that, make a fraction out of this with the magic number. Simplify the fractions. Well, 7 over 3 is simplified. It is what it is. But if you still have a fraction, which we still do, I'm going to take that number 3, put it in the front of the variable, and we got that. 12 over 3 is 4, so that's a minus 4. And there you go. There's your answer for that problem. Let's do it. 3a. It's got to be hope. I hope it's right. I'm sure it's right. A minus 4. Close it. Check your answer. Well done. See, this technique, this magic number technique, you're going to love. A lot of people don't teach it. Now, I'm going to do number 10 because this is going to generate a big, big number, and you're going to definitely want to use that website. Let me just do a quick scan of what's ahead. Oh, even better is this one. Even better is this one. Okay. Yeah. I like this one. This is even better. See, 11 and 10 and 11 is going to generate a big number. 11 is going to generate an even bigger number. So I'm going to go do 11. Do 11. Don't save this. Let's do a file, new, nice sheet of paper. Okay. Move this over here. Move that over there. A little closer. Okay. Copy the problem. 15 r squared minus 29 r plus 12. Okay, first step. Is there a greatest common factor that we can pull out? No, there isn't. You cannot pull anything out. I think the next problem that we're going to do is we're going to pull something out. But what we're going to do is take that 15 away from the r squared, and I'm going to circle it. Now, the reason I circle it is because that 15 is magic. It's involved in a lot of steps in this algorithm, and you might lose that 15 amongst all the numbers that you're generating on your paper. So rewrite the expression with an r squared. Keep the 29r the way it is. But this time what you're going to do for that number is say 15 times 12, which is 180. Oh my goodness, 180. And now you need a computer because here's the deal. I want two numbers that multiply out to be 180. Add or subtract to be 29 in the middle. See the problem? That 180, it's involved. Give me two numbers that multiply out to be 180. Add or subtract to be 29. Well, that's complicated. So you go to my website. Again, you're going to get a link to this in the course tools. What you're going to do is you're going to type in that last number, 180, hit submit, and go down to the factor pairs and find the 29. You see a 29 right there, 29. The fact that I see it there means these are the two numbers that are involved. 9 times 20. And now that you see it, yeah, 9 times 20 seems to make a lot of sense. 9 times 20, because what I'm going to do here is I'm going to say this is R and R. Double negatives. Why double negatives? Because two negative numbers will multiply to be positive and be negative in the middle. 9 and 20. 9 and 20. Of course, those would add up to be 29. Make fractions out of those numbers. Next step. 15 15. Okay, simplify the fractions. Well, 9 over 15 is a fraction, but it can be simplified by dividing top and bottom by 3. So that's going to be 3 over 5. Okay, and this is 20 over 15. I can divide top. That's not simplified. Okay, let me just copy the R minus. I can divide top and bottom by 5, 4/3. Wow. Now this expression has two fractions. If you still have fractions after you simplify, take the denominator, put it in the front. Take this denominator, put it in the front, and then you got yourself the answer. It is magic, this technique. It's beautiful. The way they classically describe how to do this in other textbooks, it's a shame they don't show you this. You're lucky you're taking this course, because this course here is one of the few courses that I've ever encountered. This magic number technique I never got taught in high school. I went to college and grad school, never saw it before. And this technique works great. Works great. Check your answer. You're going to get sick of getting things right all the time. Okay, let me just do a quick scan. I'll let you do that. Whoa, I'm not going to let you do that one. I'm going to do this one. Number 12, don't save. I'm going to go ahead and file new. Okay, now here's the deal with this problem, why I want to do this one. 8b squared minus 30b plus 18. I want to do this one because, remember that first step where you had to pull out the greatest common factor? The previous problems didn't have a greatest common factor. This one does. This one does for sure, because these are even numbers. You got to pull out the greatest common factor before you do anything. And so the thing I'm going to do here, the biggest number that goes into 8, 30, and 18 is 2. Okay, I pulled it out. That means I got to divide everything in those expressions by 2. Okay. And what we're going to do now is concentrate on this guy. Just concentrate on that. Now remember, when you plug in your answer, this 2 has to be in there. That 2 has to be part of your answer. If you don't include that 2, it's not going to be right. Because what's going to happen next is I'm going to have a set of parentheses and a set of parentheses. Now what goes in those parentheses depends on how we do the magic number. Now I'm just going to forget the 2 for now, concentrate on this, pull the 4 away from the b squared, and rewrite it into a different expression that we can factor. 4 times 9 is 36. And what I need to do, now I don't think I need the website for this guy. What we're going to do here is say, well, b and b is b squared, a couple of double negatives for the positive 36, negative middle. Two numbers that multiply out to be 36, add or subtract to be 15 is 12. 12 and 3. Yeah, that'll work. Now the next step, that's a 12. Okay, the next step is to make fractions out of those numbers. Okay, so this is b, simplify the fractions. B minus 3 is one factor, and 3/4 can't be simplified, so I'm going to take that 4 denominator, put it in front of the b, and there's your answer for this problem. Now, again, bring the 2 down. All right, I already put the 2 in my answer. I'm going to put a b minus 3 here. B minus 3, and then I'm going to move this over to 4b minus 3, and I'm going to check my answer. Jeez. Again, you're going to love math. I'm going to make you into math machines, mathematicians here. I want to do another one. I want to do another one. That's a nice one. Let's do a nice one. Close this one here. Don't save. Just a couple more and the video will be over. File, new. Okay. Well, right off the bat, take a look at this. You got cubes. We can't do cubes. The squares are hard enough. So chances are, if they give you a cube, there's something you need to pull out. And of course, every term has a y, so for sure you're going to pull out a y. Okay, so let me take a look at this guy here. Y cubed plus 57 y squared plus 18. Oh man, this is a plus 18. Everything's plus. Okay, 18y. Okay, and that's one big bundle. And we're factoring. And the idea behind factoring is you're ripping those things, that big monster bundle into smaller bundles, and those smaller bundles are called factoring. It's factors. What can we pull out? Well, we have to pull something out. Certainly y, for sure. Y is common to all the terms, so we're going to pull out a y. But what about a number? I'm leaning toward 3. I'm going to make sure, yeah, 3 will work. I can pull out a 3. Okay, pull out a 3, because what happens then is 3 goes into 45 15 times. I had 3 y's, I pull one out, I have a square. Plus 3 goes into 57 29 times. 29 times leaves you with 1 y when you pull 1 y from y squared. And then when I pull a 3 from 3 goes into 18 9 times, and I pulled out the y. Okay, good. Remember, your end answer has to have this. So I'm going to put that in my answer right now. 3y. And get myself ready for 2 more terms. Get myself ready. So, again, I've just transferred that. Now 15y squared. Well, 15. This is complicated. Let's go ahead and just pull the 15 away from the y squared. And we're going to rewrite this into a y squared term, simple y squared, plus 29y. We keep that same number. 15 times 9, I'm going to need a calculator. 15 times 9 is 135. Oh my God, 135. Thank goodness for computers and websites. We don't need to think anymore. So now what we want to do is say, well, I want 2 numbers that multiply together. Here we go. Let's get it ready. 2 numbers that multiply together to give you 135. So I'm going to say y and y, a couple of pluses, and I'm going to go to my website. I'm going to punch in that big number 135 at the end. Submit. And I'm going to search for 19. I think the answer is 19. Wait a second. Did I make a mistake? 57. Hold on. I think I made a mistake. Let's see. 57 divided by 3 is 19. 19. That's not 29. It's 19. And I still have a problem here. I'm still have a problem. I'm still having a problem. Hold on. Yeah, 135. 135. I'm looking for 2 numbers. Multiply 15 times 9 is 135. This should have been 19. This should have been 19. 19. 135 I entered. I'm not seeing 19 as an answer. What is going on here? Plus 3y, 3, 19, 3y. Oh, because I can't do math anymore. Maybe I should retire. Okay, let's start over again. Because 3 goes into 18, not 9 times, 6 times. Boy, I really butchered this problem up. Okay, I really did. I apologize for that. So let's come over here. We're still good with the 3y. We're still good with the 3y. And I'm going to take my eraser tool, and I'm going to erase all this stuff over here. Erase every little bit of this. You know what I'm going to do? I'm just going to start over again. Sorry about that. Okay, don't save. Start over again. File, new. Okay. Move this over here. All right. And basically what I'm going to do is, come on. Oh, right here. I'm going to pull out the 3y. It leaves you with, when I pull out 3y, I have 15y squared plus 19y plus 6. Okay, so when I take 3y from here, 3 goes into 45 15 times. 3 goes into 59 19 times. And 3 goes into 18 6 times. All right, there. I'm sorry. Apologize. Losing my mind. Okay, so I'm going to say, well, I got a little ahead of myself. Undo, undo. Okay, let me just go back. Control Z, Z, Z. Okay, now I need to take a look at this 15. That's the magic number. And say y squared plus 19y. 15 times 6 is 90. 15 times 6 is 90. Okay. Now this I don't, if you want to use the website, you could use the website. Okay. And say, and put in the 90. Hit enter. And I'm seeing the number 19 right there. That's what I wanted to see, the sum and difference. I want two numbers that multiply out to be 90, add or subtract to be 19. I don't think I needed the website, but I just wanted to show you anyway. Double pluses, everything was positive, 10 and 9. Now what you're going to do is, the next step is to take that magic number and make fractions out of that 10 and 9. Simplify the fractions. 10/15 is 2 over 3. See, we simplified that fraction. Y plus. Now this is 9/15. How about if we divide top and bottom by 3 to get 3 over 5? Okay, now if you still have fractions, you're going to take that denominator, put it in front. Take this denominator, put it in front. And let's minimize this guy here. You know what I'm going to do? I'm going to take this. If you still have fractions, okay, this guy here is going to give you a 3y plus 2. Put that denominator in front of the variable. And this is 5y plus 3. Check your answer. Wow, that was torturous. That's the problem. Math isn't forgiving. If you make one mistake, you're doomed. You're doomed. So you just have to have patience. Go back, start over again, and you got to believe in this algorithm. And I'm sure you'll get it right eventually. Okay, that's gonna be a double variable problem. Another double variable problem. Okay, and then I just want to check ahead. Let's do a double variable problem. Let's do this one. Okay, clear it, don't save. File, new. Okay, move this over here. Now, the double variable problem is done the same way in this section as you did in the other section. What you do to do those problems is you forget the second variable. Forget the second variable. Second variable is y. Rewrite the expression without the second variable. Without the second variable. Okay. Factor that. Now, take this problem and factor it the same way. Now, we can't pull out any 3's. There's nothing you can do here. So you need to use magic number on this. Okay, so I'm going to take the 3 away from the x squared. Rewrite another expression that looks like that, but this time you write down 3 times minus 4 is minus 12. Factor that. X and X, and I don't need any computer for this. This is going to be plus and minus for the negative 12. I'm going to put the 12 and 1 would be the numbers involved. 12 and 1. Okay, 12 and 1 will give you negative 12 right there. Okay, now make fractions out of those numbers. And simplify the fraction. So if you still have fractions, if you still have a fraction after you simplify, like 1/3 is 1/3. There's not much you can do there. Move the 3, the denominator, in front of the variable x. And 12 over 3 is 4. X minus 4. Okay, now, we're all done with the hard work. The heavy lifting is done. Okay, but unfortunately this is not the answer because there's no y's involved. See, this is the solution to this problem here. 1 times 4 will only give you 4, not the y squared, so you need to tack on to the numbers that second variable that you dismissed, and there you go. You got it done. You got it done. So what I'm going to do is write down 3x, and I really, really, really don't want you to do 1y. I don't want that. Y is better looking. And then we have x minus 4y. Let's see if that's right. Nice job. Great job. And so you got a couple of problems to do with double variables. They're not much different. And let me just see. That's a double variable problem. You can do that. An 18. Well, this is the last problem we'll do. Last problem, and then we're done with this. Okay. File. New. New. Over here. First off, I don't like the way it looks, nor do you. You got to put your 2y squared in front, minus 15y in the middle, and 27 at the end. Step 1, I can't factor anything out of that. So I'm going to take that 2, make a magic number out of that, rewrite the problem so it looks like this. 2 times 27 is 54. And by the way, that's a 15. That is a 15 right there. That's a better looking 15. Okay. I think I could factor that. I don't need a computer for that. Y and y for y squared, double negatives for the positive 54, negative middle. 9 and 6 would do the job there. 9 and 6. 9 times 6 is 54, and 9 plus 6 is 15. There you go. Make fractions out of those numbers. Simplify the fractions. Well, 9 halves is simplified. If you still have a fraction, move the denominator in front of the variable. 6 over 2 is 3. You can't get any simpler than that. And there you go. We're done. Let's see if that's right. I hope it's right. I can't take another failure. Okay, I hope you appreciate the magic number technique, because I certainly enjoy showing it to you, because a lot of people say they show it to their friends, and their friends are wowed by the technique. Anyway, have a good time. Do your homework on section 6.3. Bye.